This is part 6 of section 5.3. I want to verify this identity. We have 2 cosine squared of x over 2 equal to sine squared x over 1 minus cosine x. Now, neither side here is particularly simple. We normally start with a more complicated side and try to create the simple side. Since I don't have either side looking particularly nice, I'm going to work each side separately and hope to show that they are equal to each other. If I start off with the left-hand side, I have a half angle here that's being squared. So what I'm going to do is 2 times cosine. I'm going to use a half angle formula for cosine. It's plus or minus this square root. One plus cosine of theta, or it says theta, this will be x because, sorry, that's an x, not theta, over 2 squared. Okay, so I'm squaring the half angle formula. Now I have a plus or minus here because we don't know what angle, what quadrant we're in, but when we square it, it doesn't matter because whether it's plus or minus is going away. So what I have here is 2 times 1 plus cosine of x over 2, which is 1 plus cosine of x. And that's pretty simple, so I'm going to stop there. I can keep going if I need to, but I'm going to go over to my right-hand side. Okay. Now, since this has only cosines, I kind of want to get rid of this sine squared. I'm going to use the Pythagorean identity. Sine squared of x is equal to 1 minus cosine squared x over 1 minus cosine of x. This is a difference of squares. If I factor it, I have 1 plus cosine x times 1 minus cosine of x over 1 minus cosine of x. And then that cancels out. I have 1 plus cosine of x, and these two are equal, so the identity is proven. Okay? Now, for our last problems here, we want to find the exact value of each expression. So I have sine of 2 times the inverse sine of 1/3. Okay? So let's do what we have here. We want to find inverse sine of 1/3. Well, that's right here. So if I use the Pythagorean theorem, 3 squared minus 1 squared is 8. Square root of that is 2 square roots of 2. Okay? So sine of that, if I call that theta, and I call this angle theta, then what I have here is sine of 2 theta. Okay? Which, using the double angle formula, is 2 sine of theta cosine of theta. All right? So I've got this. I know sine of theta is 1/3. Cosine of theta is going to be the square root of 2 square roots of 2 over 3. Okay? So this is equal to 2 times 1/3 times 2 square roots of 2 over 3, which gives me 4 square roots of 2 over 9. Okay? Similar problem here. I have cosine of 2 times the inverse sine of 2/3. If I take all of this and I call it theta, I mean, I don't know what that angle is, but if I can find it, it is an angle, I just don't know what it is yet. Then I have cosine of 2 theta. And I can use my double angle formulas. And I'll be able to find the sine of that pretty easily, easier than I can find the cosine of it. So I'm just going to use this. Okay? So if my theta is equal to sine inverse of 2/3, this means that sine of theta is equal to 2/3. I wrote x here, this should be theta. I'm really bad about that, I'm sorry. So this is the same thing as 1 minus 2 times 2/3 squared. So 1 minus 2 times 4/9, 1 minus 8/9. Your final answer is 1/9.